Hello, college algebra student. This video is for chapter 3.5, transformation of function. At the end of the last video, we talked about how we can do transformation by reflection, stretch, and compression. I talked about how to do it, and we actually did some example. But actually, I want to do a demonstration with using decimal. So I'm not going to use 2 to the x. Let's use something that we know, x squared. We are aware of this toolkit function is x squared is a parabola facing up like this. So what happened is if I want to do negative outside, negative of x squared, so I multiply a negative 1. This is just actually as if you are doing negative 1 times x squared, and you can see that it's actually a reflection over the x-axis. It's vertical reflection if you are doing negative outside. And what about if I do x cubed, or maybe we'll do a square root x, okay? Square root of x. And if I do a negative of square root of x, you can see that it is up and down. It become down. And if I do square root of negative x inside, okay, so that would be inside f of negative x. So you can see that it's it is reflect over the y-axis, you reflect sideways. So anything that you multiply inside, it is going to be horizontal, so you will do horizontal reflection. If you multiply a negative outside, that's vertical. And then we also talk about stretching. Okay, so maybe we'll use square root x to demonstrate. If I just multiply 3, so you can see, oh, I don't want this. Let's use this and then just say 3. Okay, and I'm going to show. So you can see that the whole thing's like stand up. Okay, so originally 0, 0, 0 times 3 is still 0, but this y value was 1. So this y value was 1. Now 1 times 3 becomes 3. Right? If I say 4, it would just be taller. So at the same x value, it has a larger y, a multiples of y. Okay. What about if I keep the x inside, but I do a number that is 1/4 instead? Okay. Can you see that it is just smaller? So the same x value become just 1/4 of it. This is 1, but this is 1/4. So if you multiply a big number, it becomes taller. We call it stretch. You multiply a number that is like a fraction, it becomes a compression. It's kind of shorter than your original one. What happens if I have number that are multiplied inside? So if I do 2, for example, let's see what happens. So it seems like it's taller. So don't look at the fact that it's taller. Look at when does it hit 1, right? Horizontally, the graph is x equal to 1 here, but now after you do 2x, the graph is 1 in 0.5. At x equal to 0.5, it's gonna be 1. So it's as if it's growing to 1 faster. So that's what we say, you will compress it inside. We can also illustrate it by x squared. X squared. If I do the x squared inside, 2x, okay, and then square. So the black one is the original x squared, and this seems to be like taller. No, we would look at it as horizontally. Horizontally, we would have x equal to 1 will become 1. But now if you compress it, the whole graph get compressed sideways, not sideways, from left and from right, compressed to the middle. At x equal to 1/2 is already equal to 1. So you can think of it that way. And of course, if you do 2x squared, so this is actually stretching. So at x equal to 1, at x, the same x, y would equal to 2. So you look at the things in a different point of view. You look at the same x or the same y when you do your compression or horizontally or vertically. Okay, so let's go back to our 3.5 combining. So now that we learned so many kind of different transformation, what happens if I do translation, compression, and reflection all at the same time? So what is so which one should I do first? So should I do horizontal first? Do I do stretch first? Should I do shift first? Right? So the guideline is, if you are doing vertical transformation of multiplying numbers, so there's a vertical stretch or compression, and then an add, you would do the stretch first. So this is first, and this is that second. Okay. For vertical, you always do the stretch or compress first and then move it up or down. But when you're doing horizontal, there's two situations. So one situation is when the function is, it doesn't write really well, is like this, f of bx minus h. That's number 2. So if you do that, then you do the shift first and then you do the compression, okay, which is not the preferred way. So we usually do not do it this way. We usually factor it so that we have b open parenthesis x minus h. So if you see this, then we would follow the same sequence that we do with vertical, which is always do the compression first, which is compress or stretch by 1 over b, right? And then you do shift. So always remember, if you do the compression and stretch first and then do left and right, you need to factor. If you want to do the shifting first and then compress, you don't need to factor, but the compression is a little harder. Okay, so and usually we don't do it this way. So always factor for horizontal. And then number 4 is, the 4 things you need to remember is, when you're doing horizontal or vertical, they are independent of each other. So you can do all the horizontal first, all the stretch and up and down, all the stretch and horizontally, and translation or shift first, and then you do the vertical stretch and horizontal. Okay, they are independent, so you can do vertical first or you can do horizontal first. For reflection is the same as doing a stretch. So it would be nicer if you do factor, then you can do the reflection first. So let's try to mix them up together and see if we know how to do it, and also see if we can sketch a graph. Okay, so let's look at this. This has a x minus 1 inside, so we know it is left and right. It's a horizontal, right? So horizontal of right 1, right? But it's horizontal. And then this multiply outside is vertical stretch. And they don't interfere with each other, so we can do either one first. Maybe we'll just do the right one first then. So x cubed was, so we have to write ourselves a small cheat sheet here. So this is x cubed originally. We have to have it right 1, so it'll be around here like that, and then stretch by 2. So that means all the number is taller. So if you want to get the exact values, what you can do is you write the xy of x cubed, which is -1, -1, 0, 0, 1, 1. And then this is 2x minus 1 cubed would be what? I do a right 1. Right 1 means x add 1, or the x add 1. So -1 add 1 be 0. 1 add 1 is 1, and this is 2. So I should have, I should have 0, 1, 2. I should actually have like here, would go up here. And then y would be what? Vertical stretch. So multiply by 2. So multiply by 2. Y multiply by 2. X add 1, right? Y multiplied by 2, I just look at it and multiply by 2. -2, 0 multiplied by 2 is 0, and this is 2. So at 0, you should have a negative 2. I think I didn't draw it really well. At 1, you'll be 0, and at 2 is 2. Okay, you have the 2, 2. So you would draw it like a little nicer. This is a h of x equal to what? Right, yeah. h of x equal to, I thought I'm not recording, a square root of negative x plus 2. So what happened? We recognize that negative x is horizontal reflection, reflect over the y-axis is horizontally. And then at 2 is a left and right. Is it a left or right? It's supposed to be right, but because of a reflection over here, I should factor it. Negative of x minus 2. So I factor the negative one out, so this is minus 2. So if I look at this way, then I would reflect first, because we always do the parenthesis outside first, and then you can do the left and right. So this is supposed to be what? If I minus 2, it would be right 2, right? Right 2. So that means your x become negative x, and then add 2. So, so that is how you do it. So you would say, it would become, so my O1 is like this. So I reflect on this side, and then I do right 2 means I go back 1, 2. So it'll be like that. Okay. So, xy for square root x is 0, 1, 4, and 0, 1, 2, and then the negative x plus 2. So if I want like better number, so my x will, I don't change the y, right? Y is the same, 0, 1, 2. The x will change. X will be negative of it and then add 2. So it will be 2. Negative of it, negative 1, add 2. Negative 1 add 2 is 1. 4 add 2. No, negative first. So it's negative 4 add 2 is negative 2. So you can see that it is like this kind. At 2 is 0. At 2 is 0. At 1 is 1. And at negative 2 is 2. Like that. So it matches whatever that we have. 2 more. So this is what kind of transformation? I have a negative x squared, which is just a reflect over the x-axis, vertical. And then add 2 is also vertical, right? And then up 2. So we always do the reflection and transformation stretch first. So we will do reflect first. So the old one is like that. The new one would be down, and then you add 2. And then you move it up 2. So it's very easy like that, right? So if you are to build table, it would be x, y for x squared is negative 1, 1, 0, 0, 1, 1. And my x is my y that would change. Y become negative y and then add 2. So x doesn't change, 0, 1. Y become negative 1 plus 2 will be 1. Negative 2, oh, it will be 0, and then add 2 is 2. And then this is 1, because 1, negative 1, add 2 is 1. So you can see that it is like that. The last one, 1 half x cubed plus 1. So what kind of transformation do we have? We have a multiply 1 half, which is a vertical compression. So again, also vertical, compress. And we know that for vertical, we always do the compression first before we move up and down. And then this is an up 1. So my y changes, right? The y become 1 half y and then add 1. So your original y, xy, this is x cubed, is negative 1, negative 1, 0, 0, 1, 1. So your x don't change because this is only affecting the vertical. So you say negative 1, 0, 1. Y would be what? Half of it and then add 1. Half of it is negative 1. Add 1 is 1 half. Half of it is 0. Add 1 is 1. Half of it is 1 half. And 1 half at 1 is 1 and a half. So you can see that it is kind of like at 0, it become 1. Okay. And negative negative 0 is become 1, and negative 1 is just 1/2, and at 1 it is 1 1/2. So it is a more fairer